Analyzing data in research using statistics. When we look at a population and if we chart this information about a variable against number of occurrences, let's say people, their height, weight, or company's profit, and the number of occurrences of a given height, weight, or profits, we find that many of those observations congregate towards the center, and those who are at the extremes are few. For example, height of people, there's an average height, lots of people are of that similar height, and then there are very few people who are short and very few people who are very tall. So goes with weight and profit. When we stack that information against a variable that keeps changing against a number of occurrences, and when we draw it as a graph with variable on the y-axis and number of occurrences in the y-axis, variable on the x-axis, what we see is something like a bell-shaped curve. So the typical population, the variable is distributed in a bell-shaped curve against its number of occurrences. But all populations are not distributed that way. Some are negatively skewed. That means it stretches out towards the left side, and there are few extreme negative or left values and lots of positive or right values. And then there is another situation, there are very few on the right side or extremely high values, and lots of the values are towards the left side, and they congregate towards the left side. So there are normal skewed, negatively skewed, and positively skewed population. The normal skewness is considered as 0.03, close to 0. Then on the normal distribution also you can have sort of peak curve, that is peak towards the center, that's called elliptic, and then it also could be that the center is flattened and then the extremes are becoming, rather than fewer, a bit more towards the both sides of the extreme. So there's elliptic where the center is accentuated, and platycurtic where the center is more flattened and the legs become fatter, and the mesocurtic is the typical normal distribution. So in a typical normal distribution, we measure this distribution by a parameter called kurtosis, and kurtosis in a mesocurtic distribution is equal to 3. When we want to analyze data, there are 4 parameters that we can use, or 4 attributes. We call it parameters. The first one is the mean or the average. We can look at the average score. But one of the problems with this is that when there are outliers or the extreme values, the mean can change accordingly because the extreme values can pull the mean to that side. Then second parameter is called the median. Median is when we arrange the numbers from low to high values. It is the typical middle number that we take as the median. So if you have 10 numbers, if you have 11 numbers, 11 plus 1 divided by 2, that equals 6 is a typical number. If we have even numbers like 10, 10 plus 1 is divided by 2 is 5.5, and we then take the, so we can either take the two absolute numbers or and use them as typical numbers for the median. The third is the mode. That's the most frequently occurring score in a distribution. Sometimes if there's no normal distribution of the population, then and if it has several peaks, then we can have several more than one mode frequently occurring score. Now the average or the mean, median, mode, all these are computations. We look at what's the most occurring or the average score or the typical number. Especially in relation to the mean, which is the average, this average is computed using a total number which are distributed across. So this dispersion is where it helps us to come up with central values like mean, median, and the mode. And the dispersion could be measured by the range highest to the lowest value, or how the data is distributed in the population is a dispersion. But this dispersion also can be influenced by outliers. When that happens, if we want to look at the mainstream data or the mainstream facts, we can look at the middle range of the facts, or we ignore the outliers, the extreme values, or we can break into 100 parts and then decide the extreme ones and leave them out and then analyze the mainstream numbers or the mainstream distribution. So it helps us to use these parameters, the mean, median, mode, and dispersion, not only to describe our data, but also to analyze our data.